Hi and welcome to my video on kinematics and the applications of integration to kinematics. So I'm assuming in this video that you've done some kinematics and you understand it reasonably well. That is the study of displacement against velocity against time. So it's a nice little topic and it's a little bit of an application. But what I'm going to do today is show you how integration works within that area. So let's say we had x, and x is our displacement, and we have velocity, and v is our velocity, and we have a, which is our acceleration. So these are our three levels. Now we know already that to get from x to v, we just have to derive with respect to time. So these are functions based on time because they're rates of change of the distance over time. And to get from velocity to acceleration, this is also a rate of change with respect to time. So we derive to get from x to v and then from v to a. And it gives us these relationships as well, which I'll just write down here underneath, and that is that v is actually equal to dx dt, sorry if that's quite small, and a is actually equal to dv dt, and it's equal to d squared x dt squared, the second derivative of displacement. So they're the things that we've worked on before. The question now is, how do we go backwards? What if we know acceleration but we don't know displacement? And the nice thing here is that we go backwards by integrating with respect to time and integrating with respect to time. So it leads us to these secondary relationships here, that velocity is actually now equal to the integral of acceleration with respect to time, and displacement x is equal to the integral of velocity with respect to time. And there's no real second integral notation, so we just integrate acceleration twice to get displacement. It's a touch harder because we're now dealing with the extra added constant component. So let's say we took an example. Now I'm just going to state the example to you, but I'm not going to write the whole thing down. So just keep this in mind. Let's say that we gave you a function, acceleration is equal to 10 meters per second. Okay, so this is pretty standard type gravity thing. And so you'll see this a bit. And let's say that initially, so we say initially, that the particle had a velocity of 5 meters per second and it started at position 0, it started at the origin, or even if it wasn't defined, so you'd say 0. So what we're saying there is that initially means time equals 0, velocity equals 5, and initially time equals 0, x equals 0. And let's say we want to find the x, the displacement model for this function. Now, this is a constant, and when you integrate, just like when you derive, you move down the polynomials. When you integrate, you move up the polynomials. So we expect to get velocity is linear and displacement is parabolic or quadratic. These points here are going to be the things that help us to remove the constant values. So when we integrate, we get that constant of integration. So we know this. Velocity is equal to the integral of acceleration with respect to time, which equals the integral of 10 with respect to time, which equals 10t plus some constant. But we know that at t equals 0, velocity equals 5, so we get 5 is equal to 10 times 0 plus some constant, and therefore c equals 5. And that leads us to velocity is equal to 10t plus 5. Okay, I've just rubbed this off. Now we were asked to find displacement. So we've got velocity is equal to the integral of acceleration. Our displacement x is equal to the integral of velocity with respect to time. And that's equal to our velocity function, which is here, 10t plus 5 with respect to time. And that's equal to 10t squared over 2, integrate, we raise the power by 1 and we divide by the new power, plus 5t, when we integrate a constant it just becomes 5 times the variable t, plus some constant c. And this is equal to 5t squared plus 5t plus c. We also know that at time equals 0, x is equal to 0. That's given to us, that was one of our initial constraints, and so therefore x, my apologies, therefore 0 is equal to 5 times 0 squared plus 5 times 0 plus c, and therefore c is equal to 0, and x is equal to 5t squared plus 5t, or plus nothing, plus 0. And so that's it. There is our displacement model. Now questions will move on further from that. They will ask you to use this model. What's the displacement at time equals 3 or whatever. They might ask you to find velocity at time equals 3. They might ask you to find average speed, and you have to find x at 2 different points and then just work out the gradient between. So there's lots of variations of questions. The functions models that get harder. This is really common. This is what happens if you throw something and it's being acted on by the force of gravity only. But who knows what type of question you'll get. Typically it'll involve some sort of particle. But just remember that if you know acceleration or velocity, you can move back up the scale by integrating to find other values. And that's it. Thanks for watching the video. Happy days.